Thank you so much. Hello, everyone. It's great to be here. Today, I'm going to talk about the pilot project of the Israeli Ministry of Health of releasing the National Registry of Live Births. This is a joint project with my advisors, Ran Canetti. So before we jump into what exactly we did, let's talk a bit about the registry itself. So it's the official registry of Israel. It contains all the live births that occur there. Israel is rather very centralized health system, so a lot of data is exist in very central places, and this data set is very comprehensive. It covers the first few years of every newborns in Israel. And in this case, the data subject was mothers and newborns, and the curator is the Ministry of Health. The current user of this database are the Central Bureau of Statistics, the Ministry of Health, and some medical academic researchers that went through a vetting process and they can access that. The Ministry of Health believes that this data would be very useful for more data users. Fertility in Israel is a big thing. It's got the highest fertility rate in the OECD, so many people are very interested in such data. So this was starting as a pilot project of using differential privacy to make this release. We focus on a single year, just on singletons. That means birth with just a single newborn, no twins, no triplets, and so forth, just to get a sense there are 160,000 records. We are going to release only 6 columns at the beginning, but we plan to release additional in the future. So in this talk, I'm mostly going to focus about the requirements we get from our stakeholders, from the ministry and from data users, and the solution concepts we came up with. So let's start. So as we said, this is a pilot project about differential privacy. So the first requirement was about to use differential privacy for privacy guarantees. And the second requirement was about the format, the interface of this data. It should be released as table, like, think about a CSV file. It's not like we want to release just aggregated statistics. We want to release a table that people can use in Python, R, and so forth to work with that. And this was a very strict requirement from the ministry. So given differential privacy and that, it does suggest synthetic data as a solution concept. So we presented that to the stakeholder, and they said no synthetic data. And they gave two reasons. One is apparently, at least in Israel, it's got really bad reputation in the medical community of being with low quality. And second, that was I found extremely interesting, they said, well, we are the government. We cannot release synthetic data. People will say, oh, you try to hide something, right? So then, at that point, it was like, OK, this project not going to happen. But we just went to a very deep dialogue with them to understand this requirement. And I guess what we both had in mind, both the stakeholders and us, that each record should be generated from a real-world record, right? Like something like, you take one record and output another one. But after a very long deliberation, we figure out that what they actually care about is that every record that is going to be released, it's going to be correspondent to a real birth. They're going to be similar somehow. So there's not going to be errors, right? It doesn't say how we generate the data. We just kind of need to have this correspondence. So we add another requirement to have this. Each record should correspond to a single real-world birth. And of course, it goes without saying, we want high-quality data. If you want to calculate aggregated statistics on this data, it's going to perform very similar to if you would run it on the original data. So let's jump to the solution concepts, and I'm going to add to build it step after step, given the requirements made so far. So we said we want to use differential privacy and synthetic data. So we are going to take the original data. We're going to train some generative models that are going to be configured by which model family, hyperparameters, and so forth. We're going to sample synthetic data and release it to the world. The red arrows here mean this training is done with differential privacy. OK, so that's what we got so far. A big question is how to get high quality. When working with synthetic data, usually we don't have understanding of the guarantees if you run different kind of statistical queries. So we came up with the idea of acceptance criteria. So acceptance criterion is going to be a pair of an error metric between the original data and the synthetic data, and some acceptance threshold. All is predefined, all is set by our stakeholders. And the idea is after generating the synthetic data, we are going to check whether our synthetic data passes all the acceptance criteria. And only if it happens, we're going to release it to the world. So acceptance criteria think about error, about k-way marginal, conditional means, linear regression, and so forth. Whatever you want to do, you can technically put there. As you can see, there is also red arrow there. That's because we are working with the original data. Also, the acceptance criteria have to be calculated with differential privacy. OK, so far we have something. Now let's talk about the record level correspondence. So as I said before, we want to have some kind of correspondence between real world and released, real record and release record. So here we use the term faithfulness. It's a new concept we came up with. And the idea is like we're going to assure that going to be one-to-one matching between each released record and original record. And they have to be going to be somehow similar. This similarity is going to be predefined by the stakeholder. And it happened to be that when we said to people, well, there is this kind of a matching, there was no any objection to synthetic data. They were super happy with that. I was very surprised. Now, hoping to have a complete matching of all the records, that's like will be a bit too much to ask. So we're just asking for approximately. For example, in this case, well, we have this kind of matching of only for 95% of the records. And actually calculating this matching, calculating the optimal matching, the one with the highest percentage, is extremely simple computational problem with linear programming. But again, the moment we presented that for stakeholders, no, like I said, oh, synthetic data, that's fine, that's great, we are good with that. I was very surprised. And the trick is we add in this faithfulness as additional acceptance criterion. We're going to release the data only if we've achieved this, in this case it was 25%, level of faithfulness from the proposed synthetic data. OK, we were super happy. Here we go. We fulfill all our requirements. And then we went to present it to additional stakeholders within the Ministry of Health. So we presented to the head of data stewardship department. And it was kind of, well, it was first no. This stakeholder was less engaged with, less eager or engaged to understand differential privacy. And this is great because this is a realistic stakeholder for post-release. And they came up with their own notion of what is private. I won't get into it, but it's something like complete key anonymity. It's key anonymity for all possible columns. That's how they thought it should be. And they actually really said, I have this quote, private governmental data released to the public cannot contain unique records, no matter what. This, when people think about their expectation, what is a privacy, if they would see a unique records, that's not going to work. So together with our primary stakeholders, given that we have formal guarantee of differential privacy, we included no unique row guarantees. Now, actually, for this kind of expectation of people about privacy that does not give formal privacy guarantees, we call it face privacy. If you're familiar with the term first validity, is inspired by that. First reaction was actually, we need to push against that, but that's maybe in the long term of, we need to educate people, educate stakeholders, and so forth. But if currently people have this expectation about privacy, and we can satisfy that without, of course, hurting the utility and the formal privacy guarantees, we decided to fulfill it. So again, to do this face privacy, we actually just doing post-processing on the release data before we release it, right? So this is what we call the projection. We take the data set and just simple post-processing. Important thing is like the acceptance criteria now are being calculated about the release candidate data set, right? Because we want to make sure that what we actually going to release is going to satisfy our utility constraints. OK, so there are many more issues I'm not going to talk about right now, but feel free to reach me up. What I described here is just one run of this scheme end-to-end. And if I run multiple times until it's going to pass all the acceptance criteria, I will have a meaningless privacy loss budget. But we use private selection to address that. Question of how to allocate the privacy loss budget, what are the space of configuration, what are the acceptance criteria and how to design them, and more other issues. And of course, communication plays here. So we are going to live actually, hopefully this week, maybe next week. Last week, we actually ran the pipeline and we get a result. Total epsilon is going to be 9.98. Finally, we, from the beginning, said it shouldn't be above 10. Of course, we got really close to that. And we're going to first release the data as a CSV file and a README file, and hopefully later this month, releasing also all the code and very detailed technical report. We believe that we want to, the technical report actually contains really ruthless reflection of all the things we could do better, because I think this is we're really missing that, to have more use cases published with all what went well and wrong. Yeah, and I will conclude with that. I think this kind of example of faithfulness and face privacy, showing the kind of what it's meant to do code design. Our stakeholder were very involved with all of our decision in the process. So this was an important aspect of that. And that's all. Thank you so much.